We perceive solid objects, like a crystal wine glass, as rigid, unchanging structures. But that absolute rigidity is a sensory illusion. Under enough magnification, this glass is highly dynamic. It is constructed from an atomic lattice, an interlocking geometric grid of physical bonds holding billions of atoms together. This microscopic grid behaves elastically. It allows those atoms to shift and vibrate for fractions of a second without breaking their structural bonds. When a kinetic impact, like the tap of a metallic sphere, strikes the rim, it sends a wave of displaced energy rippling straight through that flexible grid. At this scale, the glass functions as a dynamic system, primed for energy input. Every object possesses a specific mass, a unique shape, and architectural stiffness. Together, these properties create a strict mathematical constraint on how the object can process incoming kinetic energy. This constraint dictates the object's natural frequency, the inherent, unforced rate of oscillation a system naturally settles into when it is disturbed. We experience this invisible physics concept every time we tap a glass. The singular, specific pitch you hear is the sound of that oscillation. This chart visualizes that ringing as a data point. That 540 Hz pitch is the exact mathematical signature of the lattice vibrating at its natural frequency. This frequency acts as an absolute speed limit for how fast the system dissipates kinetic energy. It dictates how the glass returns to rest, creating a catastrophic vulnerability if deliberately exploited. Identifying an object's natural frequency provides the precise coordinates required to weaponize its own structure. To exploit that vulnerability, we introduce a continuous external acoustic pressure wave aimed directly at the glass. First, we apply an input wave that is deliberately mismatched to the structure's speed limit. This diagram visualizes that physical collision. A cyan 400 Hz input wave strikes the 540 Hz waveform of our glass, and the two frequencies violently clash, scattering into chaotic static. At 400 Hz, the external pressure wave completely fails to move the glass because the wave phases are mathematically misaligned. The energy from the misaligned incoming wave pushes against the natural outward rebound of the lattice. The opposing forces effectively cancel each other out. To bypass this energy rejection, the external input wave must be dialed up to perfectly match the object's speed limit. When the input ticks up to exactly 540 Hz, the incoming cyan wave aligns perfectly, crest to crest with the glass's natural waveform, merging cleanly into a single taller wave. At this exact 540 Hz alignment, the kinetic energy stops bouncing off. It becomes permanently trapped within the atomic system. This alignment triggers a process known as constructive interference. Constructive interference occurs when the crests and troughs of overlapping waves perfectly align in both space and time. Instead of canceling out, these aligned waves mathematically add their kinetic energies together. This addition forces the physical rim of the glass to warp further outward with every passing cycle. You can visualize this transfer of energy by picturing a child being pushed on a playground swing. Pushing randomly against the swing's momentum simply wastes your energy and halts the motion, exactly like the 400 Hz failure. But a push delivered at the exact millisecond of the swing's natural peak effortlessly compounds the kinetic energy. The continuous 540 Hz acoustic wave acts as thousands of microscopic, perfectly timed pushes every single second. Each passing cycle of the acoustic wave hits the atomic lattice at the exact microsecond of its natural outward flex. Because the energy cannot escape, it remains stored in the lattice, waiting for the next overlapping wave to add to it. This kinetic energy is stacking hundreds of times in the blink of an eye. The phase-aligned sound wave creates a self-reinforcing cycle of kinetic stacking inside the glass. This trapped energy demands a physical consequence. That consequence is amplitude. Amplitude is the physical width and maximum displacement of the object's vibration from its resting center, while the frequency, the speed of the vibration, remains strictly locked at 540 Hz. The amplitude is completely unbound. Through the relentless kinetic stacking of constructive interference, the amplitude grows continuously. The physical walls of the glass are now bending distances they were never architecturally designed to reach. This is a runaway mathematical loop. The amplitude will increase unstoppably. The geometric shape of the glass is now acting as a trap, hoarding kinetic energy it cannot physically contain. This terminal state is called acoustic resonance. Acoustic resonance is the climax of this process, a system absorbing maximum energy from an external wave that perfectly matches its natural frequency. Scaling back down to the atomic level reveals the severe architectural strain caused by this escalating amplitude. It is a common misconception that the sound wave is acting as a blunt force hammer, striking the glass from the outside. The external wave is feeding energy into a trapped system. The glass is actively vibrating itself to death. The object has reached a point of no return, where its own fundamental architecture facilitates the kinetic force driving it towards destruction. The physical bending of the crystal structure eventually reaches its absolute limit. The moment of failure arrives when the trapped kinetic energy of the vibration exceeds the physical binding energy holding the atoms together. The microscopic collapse is instantaneous, as the geometric bonds tear apart simultaneously across the entire lattice. At the macro level, the rigid structure violently explodes outward. This destruction results from phase-aligned kinetic energy reaching the threshold of mathematically precise structural failure.